How can you tell if a system is in simple harmonic motion? There are three telltale signs that a system is in simple harmonic motion. The first being that the force acting on the system is linearly proportional to the displacement. This means that if the force increases, then so does displacement. The second sign is that the period is independent of the amplitude. This means that the period is not affected by the amplitude in any way. Lastly, the motion represented by a position versus time graph is a sine wave graph. You can also tell if a system is in simple harmonic motion based on its graph. The graph on the left is of a simple harmonic motion system, as the graph is constant. The graph on the right has varying amplitudes, making it not in simple harmonic motion. Suppose you have a spring system where the spring is at rest, stretched out, then released. The spring is then compressed, and then the spring again oscillates and goes back to equilibrium. The position versus time graph would look like this, where it starts off at 0 or equilibrium, goes to a max positive amplitude since the stretch is to the right, passes equilibrium, and then goes in the negative since the block is to the left now. The velocity versus time graph would look like this. Velocity is the greatest when the block is at equilibrium because it is moving the fastest here. When the block is stretched and compressed, the velocity is 0 as the system slows down a bit once it reaches these high points. This is the acceleration versus time graph. Acceleration is 0 in the beginning because it is at equilibrium and there is no change in velocity. Then it goes to a negative maximum because while the block is to the right, the force on the block is going to the left. When the spring is compressed, the graph is positive because the force is to the right. You can look at a position versus time graph to determine the maximum positive velocity, which is at equilibrium when the graph is going in the positive direction. Maximum negative velocity is at equilibrium and is when the graph is going in the negative direction. Zero velocity is at all of the endpoints. You can also find the acceleration by looking at a position versus time graph. There is maximum positive acceleration at the largest point of the graph in the negative, or at the negative amplitude. There is maximum negative acceleration at the largest positive endpoints of the graph, and there is zero acceleration at the equilibrium. Thank you for watching, and we hope that you now learned about simple harmonic motion in identifying graphs, finding out whether it is a simple harmonic motion system, and even solving equations.